so what we're going to do here basically is solve simultaneous differential equations. All right. Okay. Now before I actually go on to the topic, okay, I want you to recall certain formulae, certain concepts which you've already learned, so that these concepts will be used in the course of the problems. So let's first recall. Let's have a quick recap of what we've already seen. Okay. So the first thing that you need to know is Laplace transform of derivatives. So you need to know these two formulae. All right. So what is Laplace of y dash of t? Now, by the way, what is this y dash of t? It is the derivative of y. Okay. Y dash of t is dy by dt. What is y double dash of t? D square y by dt square. It's the second order derivative of y. Okay. So these are formulae for Laplace transform of derivatives. So what is L of y dash of t? It can also be simply written as L of y dash. And what's the formula? It is yes L of y minus y of 0. Okay. Similarly, we have a formula for L of y double dash of t, which can simply be written as L of y double dash. And that is equal to s square L of y minus s y of 0 minus y dash of 0. Okay. Now I can just extend this formula to any number of derivatives. In fact, what do you think will Laplace of y triple dash of t would be? It is Laplace of y triple dash, and the formula will be s cube L of y minus s square y of 0 minus s y dash of 0 minus y double dash of 0. It will end with y double dash of 0. So you can just extend this formula to any y power n of t. Fine. Okay. But for the problems that we have here, it's enough if you know these two formulae. Fine. Okay. The second thing that you have to know is convolution theorem. Now this is for inverse Laplace transform. Okay. So the statement that is given here, the second one, is for inverse Laplace transform, convolution theorem for inverse Laplace transform. So how does it go? The statement, L inverse of f of s into g of s is equal to L inverse of f of s convolution L inverse of g of s. So when can I apply this theorem? When I have to find L inverse of product of two functions, where one is f of s, the other is g of s. Only then I can apply this theorem. And according to this theorem, it will be L inverse of the first function, convolution L inverse of the second function. Okay. Now the third thing that you have to know is the definition for convolution. Now convolution, just like any other, operator, it's basically an operator which operates on two functions. Okay. Just like how you have addition, subtraction, which operate on numbers. This is also basically an operation which operates on two functions. Okay. So f of t convolution g of t is defined as integral 0 to t f of u g of t minus u du. Okay. So what is f of t convolution g of t? It is integral 0 to t f of u g of t minus u du. Okay. So I want you to remember all of them and this. Now this is method of partial fractions. Now when you take inverse Laplace transform, there are two important methods that you need to know. One is convolution, the other is convolution theorem, that is. The other is method of partial fractions. Okay. Now this is the easier one. I'm sure you've all done this in school, so this should be familiar to you. Okay, let's quickly go through the three cases under method of partial fractions. Remember, when can you apply this? Only when the degree of the numerator is strictly less than degree of the denominator. Okay, this is when you can apply method of partial fractions. All right. So what are the three cases that we have? Let's say you have product of factors in the denominator where all of them are linear and not repeating. Okay. Now what do you mean by linear factor? Any factor which is of degree 1. Okay, like s plus a is a linear factor. S plus b is a linear factor. Why? Because it's of degree 1. Fine. Okay, so if I have, look at case 1, all of you. If I have f of s divided by s plus a into s plus b, how can I write this as? I can write this as a by the first factor plus b by the second factor. Okay, so this is when you have linear factors not repeating. Now let's look at case 2. Let's assume that the linear factors are repeating. Now, what do you mean by repeating? If you have whole square or whole cube, like what you have here in case 2. Look at the left hand side. If you have f of s divided by s plus a the whole square into s plus b, how can you write this as a by s plus a plus b by s plus a the whole square plus c by s plus b? You know, s plus b is not repeating, so I will just have it once. Okay. Now, let's say you have s plus a the whole cube. Then how will you write this as the same function as a by s plus a plus b by s plus a the whole square plus c by s plus a the whole cube plus d divided by s plus b. Okay, that's how it will be when the linear factors are repeating. This is case 2. Now I want you to look at case 3. Let's say you have f of s divided by a quadratic factor. Now, what do you mean by quadratic factor? Any factor which is of degree 2 is said to be quadratic factor. Okay, so something like this, something like what we have in case 3. What if you have f of s divided by s square plus a into s plus b? So here s square plus a is obviously a quadratic factor because it's of degree 2. It has s square, isn't it? So how do I write this as as plus b divided by the quadratic factor s square plus a plus c divided by s plus b, because s plus b is just a linear factor. So that I will follow case 1 there. Have you understood? So this is basically partial fractions that you need to know, which we will apply in the course of the problem when we want to find inverse Laplace transform. Okay, so both method of partial fractions and the convolution theorem that we saw will be used while finding inverse Laplace transform. Fine. All right, let's proceed now. Now, this is something that is just purely a general concept. Okay, I wanted to explain this because I felt like you will understand our topic even better. All right. So this is something that general that you already know. Like, what if you have 2 equations with 2 unknowns? Okay, let's just read the question. Supposing you have 2 equations, 2x plus y equal to 4 and x minus 4y equal to 11. And I say solve. Then what are you supposed to do? You're supposed to find the values of x and y which satisfy these 2 equations, isn't it? So how will you do it? How will you find x and y? You will try to bring the same coefficients for x or y, isn't it? And then add or subtract. So that is what I've done. I've kept equation 1 as it is. Look at the coefficient of x in equation 1, it is 2. Look at the coefficient of x in equation 2, it is 1, right? So what will I do? I will try to bring the same 2x in equation 2 also. So what should I do for that? I should multiply equation 2 by 2, isn't it? Only then I'll get 2x. So I've written equation 1 as it is and I multiplied equation 2 by 2 throughout. Why? Because I wanted to bring the same coefficients for x. And then I simply subtracted. I found the value of y. Once I found the value of y, what did I do? I mean, what should you do? Substitute y in either equation 1 or 2 to find the value of x. And then you're through. So we're going to use the same concept in solving simultaneous differential equations. So I want you all to keep this in mind. Fine? Okay, let's go ahead. Now we're going to the actual topic. All right. Now, as I told you, what are we going to do here? We're going to apply Laplace transform. Please remember, this is an application of Laplace transform that we are learning. So we're going to use Laplace transform here. And what is the objective of the problem? We're going to solve simultaneous differential equations. Fine. Now, what do you mean by the word simultaneous? Now, if you have 2 differential equations taken together, they are called simultaneous differential equations. Okay. So in every problem that we have here, you will have 2 differential equations in the question. That's why it's called simultaneous differential equations. Fine. The next thing, we're going to solve. Now, what do you mean by solve? In other words, what are you asked to do? Now listen carefully. Look at the question. Both are differential equations in x and y with respect to t. I hope you can see that. Okay. I have dx by dt. And in the second equation, I have dy by dt. What does that mean? These are differential equations in x and y with respect to t. Now the question says solve. So what are you supposed to do? You're supposed to find the values of x and y which satisfy the 2 given differential equations. Have you understood? So this is the objective of the problem. What is your aim? What is your objective? Your objective is to find the values of x and y which satisfy the given differential equations. Is that clear? So I hope you've understood what we're going to do here basically. Okay? We will be given two differential equations simultaneously. We will be asked to solve, which means we will find x in terms of t and y in terms of t. Okay? All right. Now I want you to read the question further. If you read, you will notice that there is one condition given. And this is called initial condition. Why? Because it's a condition at t equal to 0. Okay? Now let's read the condition. It says x is 2 and y is 0 when t is 0. Okay? So in other words, see, x and y are both functions of t. Okay? So when I say x is 2 when t is 0, what do I mean? I mean x of 0 equal to 2. Similarly, when I say y is 0 when t is 0, what do I mean? Y of 0 is 0. Okay? Because here x is nothing but x of t. Okay? So when I say x is 2 when t is 0, I mean x of 0 is 2. Similarly, y of 0 is 0. Now this is the question. So you all know what you're going to do now. You're going to find the values of x and y. So let's begin the solution. Fine? Now step 1, I'm going to tell you in steps. Okay? Every problem will have 6 steps. So it's really easy for you to understand the procedure. So step 1, let's begin with step 1. First step, all you have to do is replace dx by dt by x dash and dy by dt by y dash. It's just a notation. I can do that. So simply replace dx by dt by x dash, dy by dt by y dash. So I've got the first two equations, x dash plus y equal to sine t, y dash plus x equal to cos t. Step 1 is over. Okay. Now let's go on to step 2. What do you do in step 2? You straight away apply Laplace transform on both sides. Straight away apply, because you know you're going to use Laplace transform to solve these differential equations. So in the very beginning, you're going to apply Laplace transform on both sides in the given two differential equations. So what will you get? L of x dash plus L of y equal to L of sine t. Similarly, in the second equation, L of y dash plus L of x is equal to L of cos t. I've simply applied Laplace transform on both sides and I've applied linear property, obviously. Only when you apply linear property, you can take the L inside. Okay? All right. So have you understood so far? So 2 steps we have done. First step, we replaced dx by dt by x dash, dy by dt by y dash. Over. Now we went to step 2. What did we do there? We simply applied Laplace transform on both sides. Okay? Step 2 is over. Now let's go on to step 3. What do you think we will do in step 3? We will simplify these two equations. Now you all know what is L of x dash. I hope you remember the recalling that we did in the beginning. The formula. I have to use Laplace of derivatives formula. Okay. So use the formula for L of x dash. Use the formula for L of y dash. And of course, you should know what is L of sine t and L of cos t. Okay. I hope you remember the formula. What is Laplace of sine at? It is a divided by s square plus a square. What is Laplace of cos at? It is s divided by s square plus a square. Okay, so that is exactly what I've done in step 3. Let's move on. Look here. What is L of x dash? S L of x minus x of 0 plus L of y is written as it is equal to, what's the right hand side? Laplace of sine t. What is Laplace of sine t? 1 by s square plus 1. I've written the formula I've highlighted it in yellow. Please look at that. That's the formula for Laplace of sine at. I've simply used it here. Okay. How did I get the second equation? Look at the last step here. What is Laplace of y dash? It is s L of y minus y of 0. Okay, that's the formula. Plus L of x is written as it is equal to, last thing I have, L of cos t. What is Laplace of cos at formula? S by s square plus a square. What is Laplace of cos t? S by s square plus 1, because a is 1. Okay, have you understood so far? Now, I'm going to use the initial conditions given in the question. This is where I'm going to use it. See, what is x of 0? What is y of 0? Simply look at the question, you will know. Question says, x is 2 when t is 0. What does that mean? x of 0 is 2. Similarly, y of 0 is 0. This is what I've written. I've highlighted it in yellow. Hope you can see that. So this is given in the question. Let's use that here. Okay. So what will I get? I'll get yes L of x minus 2 plus L of y equal to 1 by s square plus 1. Similarly, replace y of 0 by 0. You will get the fourth equation. Have you understood so far? Step 3 is over. This is step 3. So what did we do in step 3? We used the formula for L of x dash. We used the formula for L of y dash. And in the right hand side, we used the formula for Laplace of sin t, Laplace of cos t. And then we used the initial conditions given in the question. And then we've got equations 3 and 4. Now, I want you to remember this. Equations 3 and 4, when you form, it should be in the standard form. Now, what's the standard form? First term should always be the L of x term. Then you should write the L of y term. Then take all the other terms to the right hand side. In fact, I should have taken that minus 2 also to the right hand side. So when you take minus 2 to the right hand side in equation 3, it will be plus 2 in the right hand side. Okay, that's the standard form of equations 3 and 4. Will you remember this? First write the L of x term, then write the L of y term, and take all the remaining terms to the right hand side. Those are your equations 3 and 4. Fine? So step 3 is over. Now, what will I do from here? Listen carefully. This is where we're going to apply that concept. You remember I told you about 2 equations with 2 unknowns? That's exactly what I'm going to do here. Now I have equations 3 and 4. Both are equations with 2 unknowns. What are my 2 unknowns now? L of x, L of y. Okay. So what will I do? I will try to eliminate one variable from the picture. I will try to eliminate either L of x or L of y. Okay. Now let's say I want to eliminate L of y. What should you do then? Look at equations 3 and 4. How will you eliminate L of y? The equation 4 has yes L of y. Equation 3 has only L of y. So what should you do to equation 3? Multiply that by yes. You understand? Only if you multiply L of y by yes, you will get yes L of y. And then you already have yes L of y in equation 4. So simply if you subtract, L of y will be gone. And you will have an equation in L of x alone. You understand? So I'm going to treat these 2 equations as 2 equations, 2 unknowns. What are the 2 unknowns? L of x and L of y. So what I'm going to try and do, I'm going to try to bring the same coefficients for L of y in both the equations so that I can subtract and make it disappear so that I get an equation in L of x alone from which I will find x. Okay? All right. So we go on to step 4. So in step 4, what do? I'm going to, as I told you, multiply equation 3 by yes. Okay? So multiply equation 3 throughout by yes. So what will you get? S square L of x plus yes L of y equal to s by s square plus 1 plus 2 into s. Okay? I multiply it throughout by s. And what have I done to equation 4? I have not disturbed it at all. I have just written it as it is. Okay? All right. Now I'm going to subtract. Why subtract? Because only if I subtract, L of y gets cancelled. Okay? So let's subtract. So L of y is out. So I have an equation in L of x now. So what is the coefficient of L of x on the left hand side? See, the first equation I have s square. Second equation I have minus 1. So I will have s square minus 1 into L of x is equal to right hand side s by s square plus 1 minus s by s square plus 1 gets cancelled. So what is the only term that I have? 2s. Okay? So what have I done? I've successfully eliminated L of y. And I've got an equation in L of x alone. So what is my L of x now? It is 2s divided by s square minus 1. I've brought s square minus 1 to the other side. Okay? So what is L of x? 2s divided by s square minus 1. Now people, what's our aim? What's our objective? Our objective is to find x and y. Now I have L of x. So how will I find x from there? I'll have to use inverse Laplace transform. Okay? So what is x? If L of x is 2s by s square minus 1, what is x? It is L inverse of 2s by s square minus 1. Okay? Now 2 is just a constant. You can take it outside. What is L inverse of s by s square minus 1? It's in the standard form. L inverse of s by s square minus a square is cos h a t. Now here a is 1. So what is L inverse of S by S square minus 1? It is simply cos ht. Have you understood? So what have we done? We've found x. Okay, we have successfully found what is x. Now, the problem is not over. Remember, you have to find y also. Okay, so now we found x in terms of t. Let's find y in terms of t. Now, you remember what we did there when you have two equations, two unknowns. Once you find one variable, how will you find the other variable? You will simply substitute this in one of the two given equations to find the other variable y. That's exactly what we're going to do. This is the very last step. Okay, so we know x now. How do we find y? We will substitute this value of x in one of the two given equations. So let's go back to the given two equations. Look here, read the question. I mean, in the solution, you have equations 1 and 2, right? They are the given equations. So what I'm going to do is, I'm going to substitute x here in one of the two equations to find y. Okay? Now you tell me, you think, which equation should I use to find y? Which equation will give me y directly? That's the equation that I will take. I will not take equation 2 because equation 2 will give me only y dash. I want y. So which equation gives you y directly? Equation 1. Okay. So we're going to substitute x in equation 1 to find y. So from equation 1, what is y? Y is sine t minus x dash, isn't it? So this is the last step. To find y, I'm going to substitute x in equation 1. And according to equation 1, what is y? It is sine t minus x dash. Okay? So it is sine t minus, what is x dash? Dx by dt. You know that, right? It's the first derivative of x. So it is sine t minus, what is x? Just now we found x. X is 2 cos ht. So what is x dash? X dash is 2 sine ht. Okay? I've replaced x dash by 2 sine ht. I want you all to remember this formula, okay? See, differential of sine ht is cos ht. Differential of cos ht is sine ht. For both, it is plus. These are hyperbolic functions, okay? So please remember, differential of sine h is cos h. Differential of cos h is sine h. For both, it is plus. So that's it. We have successfully found the values of x and y. And therefore, the problem is over, okay? So I hope you remember the steps that we followed. See, this is the most important application of Laplace transform, okay? And it's a favorite among the examiners. And usually there's no subdivision. It's a full straightforward question. You get the full marks when you answer this, okay? So I want you to really concentrate on what we are doing. We're going to do a few more problems, of course. But every problem is going to be different in some way. But the basic procedure is exactly the same. Shall we quickly recall what we did? First step, step 1, what did we do? We replaced x dash by dx, we replaced dx by dt by x dash. We replaced dy by dt by y dash. That is what we did in step 1. What did we do in step 2? We applied Laplace transform on both sides. Okay, that is all we did in step 2. What did we do in step 3? We used the formula for Laplace of x dash, L of x dash. We used the formula for L of y dash. We also used the initial conditions given. Okay, and then we brought equations 3 and 4. Remember equations 3 and 4? You should have L of x term, L of y term. Take all the other terms to the right hand side. So you get equations 3 and 4. This is step 3. Step 3 is over. What did we do in step 4? We eliminated one variable. I said take these two as two equations, two unknowns. Eliminate L of y or L of x. Okay? So if you're eliminating L of y, you will get L of x. Fine? That is step 4. What is step 5? From L of x, find x. How will you do it? Using inverse Laplace transform. Okay, this is step 5. And what is last step? Step 6. Substitute x in one of the two given equations to find y. Okay? That, and then you're through. So you have six steps that you follow for any problem here. So even though it's a little lengthy, be a little patient. I'm sure you're going to arrive at the answer. Fine? Okay, so this is the first problem. Let's move on to the second problem. As I told you, every problem is going to be slightly different in some way. So let's see what it is. All right. This is the second question. Fine? All right. So what does it say? Solve the simultaneous differential equations 2 dx by dt plus dy by dt equal to 5 into e power t. and dy by dt minus 3 dx by dt is 5. So I have two differential equations because these are simultaneous differential equations. I've been asked to solve it. So what am I supposed to do? I'm supposed to find the values of x and y which satisfy these two equations. Okay, so my aim is to find x in terms of t, y in terms of t. Then I'm through. Okay, all right. What else is given in the question? It also has initial condition given. Okay, why do I say initial condition? Because it's the condition at t equal to 0. Okay, so what does it say? When t is 0, x is 0. What does that mean? X of 0 equal to 0. Okay, what is the other condition given? When t is 0, y is 0. In other words, y of 0 is 0. Will you remember these two conditions? X of 0 is 0, y of 0 is also 0. Okay, all right, let's go ahead with the solution. So let's start with step 1. What is step 1? Simply replace dx by dt by x dash, replace dy by dt by y dash. Okay, so what do you get then? You get equations 1 and 2. 2x dash plus y dash equal to 5 e power t. That's the first equation. What's the second equation? Y dash minus 3x dash equal to 5. I hope you're all with me. Step 1 is over. All right, let's go to step 2. What is step 2? Apply Laplace transform on both sides. Okay, so what will you get then? You will get 2L of x dash plus L of y dash equal to 5 into L of e power t. 5 is just a constant, you can take it outside. And this is, how do you get this step? By using linear property. Okay, I can take the L inside. All right. And what about the second equation? When you apply Laplace on both sides, you will get L of y dash minus 3L of x dash is equal to L of 5. Okay, step 2 is over. Fine, let's go on to step 3. Now, what do you think we will do in step 3? We will use the formula for L of x dash. We will use the formula for L of y dash. We will also write what is L of e power t, what is L of 5. Okay, so let's substitute. So I'm going to substitute for the first equation first. Fine, so 2 into L of x dash. What is 2 into L of x dash? It is 2 into yes L of x minus x of 0. I've simply used the formula for L of x dash plus L of y dash. What is L of y dash? Yes L of y minus y of 0. Okay, equal to, look at the right hand side, I have 5 into Laplace of e power t. Now what is Laplace of e power t? 1 divided by s minus 1. Okay, I've written the formula in the highlighted yellow color thing, so you can always refer to the formula there. Okay, Laplace of e power t is 1 by s minus 1. Now, how did I get the second equation? For that, look at the last equation here. What is Laplace of y dash? It is yes L of y minus y of 0 minus 3 into L of x dash. Yes, minus 3 into, what is L of x dash? Yes, L of x minus x of 0. Okay, equal to, what's the right hand side? Laplace of 5. What is Laplace of any constant? That constant by s. So this is 5 by s. Have you understood? Now remember, step 3 is not over. I have to use initial conditions now. Okay, so let's use the initial conditions. What was given in the question? Given that x of 0 is 0 and y of 0 is 0. I've highlighted it in yellow. I hope you can see that. So let's use the initial conditions here. So what happens to the given equations? It becomes 2s L of x plus yes L of y. Take all the other terms to the other side. Now anyway, for us this is really easy because x of 0 is 0, y of 0 is also 0. So they just vanish. Okay, so this is equal to y by s minus 1. So 5 by s minus 1. Similarly, the next equation, remember I told you the format for equations 3 and 4. How should you write? You should write the L of x term first, then the L of y term, then take all the other terms to the other side, I said. Okay, so I will write first L of x term minus 3s into L of x. Then I will write the L of y term, s into L of y. Okay, equal to 5 by s. Have you understood? Step 3 is over. Now we go on to step 4. Now what should you do in step 4? You have to treat these two equations as two equations with two unknowns. Okay, and eliminate one variable. So either eliminate L of x or eliminate L of y. Okay, so what have I done? See here the problem is really simple because look at equations 3 and 4. Both have s into L of y. isn't it? So I don't have to think and try and bring the same coefficients. I don't have to do that. Already I have the same coefficients. So all I have to do now is simply subtract, isn't it? Equations 3 and 4 have s into L of y. So simply subtract the two equations. So what happens now? L of y is gone. So I have just L of x. So 2s minus of minus becomes plus, okay? Plus, so it's 2s plus 3s, which is 5s. 5s L of x is equal to, right hand side, remember I'm subtracting. So it's 5 by s minus 1 minus 5 by s. Have you understood? Now, so this is step 4 that we're doing. What are we doing? We are eliminating one variable. So we have successfully eliminated L of y. So I have only L of x now. Fine. Now, simplify. Find L of x exclusively. So you have to have L of x on one side, bring all the other terms to the other side. Only then step 4 is over. Now, what have I done? First thing, I've cancelled all the 5. Do you see a 5 that is common in all the terms? From the last step, the third step. I'm talking about the third step from the last. There is a 5 that is common throughout. So I've cancelled all the 5. Okay. Then I've taken LCM for the right hand side. What will be the LCM for the right hand side? S into s minus 1. Isn't it? Okay. What will be the numerator? S minus of s minus 1. So s gets cancelled. You're left with 1. Okay. So what is L of x? L of x is 1 divided by, bring the s to the other side. You will get s square into s minus 1. Have you understood so far? What have we found? We have eliminated L of y from the picture and we have found what is L of x. Okay. So this is step 4. Step 4 is over. From this, what do you think you're going to do in step 5? From this, you're going to find x. So what do you think x is? If L of x is this, what is x? X is L inverse of the right hand side. L inverse of 1 divided by s square into s minus 1. You understand? So that's step 5. We're going to find inverse Laplace transform. And I hope you remember the two methods that are the most important in as far as inverse Laplace transform is concerned. One is convolution theorem. The other is method of partial fractions. Okay. Now method of partial fractions is the easier one. And it's a favorite amongst the students. It's also a favorite for me. But you also should know convolution theorem because it's a very, very important concept. And it's also, important exam point of view. Fine. That is also an interesting one. So I want you to know that as well. So this particular problem from here, you can use partial fractions. But since you can also use convolution theorem, I've used convolution theorem for this particular problem because I want you to understand that also. Okay. So what is x? X is L inverse of 1 by s square into s minus 1. So I'm going to go on to the next page. Listen carefully. Okay. Now, I don't want you getting scared. Okay. This is going to be really easy. Trust me. Now, what is x? It is L inverse of 1 by s square into s minus 1. Isn't it? Now, as I told you earlier, you can also use partial fractions from here to find x. To find this L inverse of this function, you can use partial fractions. How? You see in the square brackets, I've explained in the square brackets. You can also use partial fractions. How will you do it? You're going to separate the factors. See, what is partial fractions all about? It's all about separating the factors so that you can find L inverse easily. Okay. See, when you look at the first step, it's obvious that you cannot find L inverse of 1 by s square into s minus 1 straight away because there is no formula to find. Isn't it? That is why we are either going for method of partial fractions or convolution theorem. Now, since this is product of factors, you can separate the factors using partial fraction. How do you do that? Look at the ones that I've written inside the square brackets. 1 by s square into s minus 1 can be written as a by s plus b by s square because linear factor repeating, okay, plus c by s minus 1. And you can proceed, find a, b, c and proceed. That is one way of doing. But this particular problem can also be done using convolution theorem. So I want you to know what is that, okay? All right, so let's go ahead. Now, what is convolution theorem? This is again a recap. We've already done the recalling. I hope you remember. I want you to concentrate on the highlighted one, the yellow highlighted one, statement of convolution theorem. What is L inverse of f of s into g of s? It is L inverse of f of s, convolution L inverse of g of s. Okay, so let's use this theorem here now. Please listen carefully. 1 by s square is my f of s. 1 by s minus 1 is my g of s. Okay, so what is L inverse of f of s into g of s? It is L inverse of f of s. So L inverse of 1 by s square, convolution L inverse of 1 by s minus 1, which is my L inverse of g of s. Have you understood? In place of f of s, I have 1 by s square. In place of g of s, I have 1 by s minus 1. So all I've done is use convolution theorem here. Okay, all right. Now you have to use the formula. You have to know this. What is L inverse of 1 by s square? It is t. See, the formula is this. L inverse of 1 by s power n plus 1 is t power n by n factorial. I hope you got that. L inverse of 1 by s power n plus 1 is t power n by n factorial. Okay. So L inverse of 1 by s power 1 plus 1 will be t power 1 by 1 factorial. So I've just written t. Convolution. What's the next term? L inverse of 1 by s minus 1. What is L inverse of 1 by s minus 1? E power t. Okay. See, all these results, L inverse results, are got from L results only. You know the 8 basic results from Laplace transform, right? See, Laplace of e power at is 1 by s minus a. Now take L to the other side. What is L inverse of 1 by s minus a? It is e power at. So all the 8 results that we have here in inverse Laplace transform are got from the 8 basic results that we have in Laplace transform. So do not get worried. Okay, you know them all. All right. So what is L inverse of 1 by s minus 1? It is e power t. Now, what do I have here? I'm talking about the 4th step. I have t convolution e power t. I need to find this. For that, I'm going to use convolution definition. Okay, you remember this also we did in the recalling. What form is this? F of t convolution g of t. And what is the formula for f of t convolution g of t? It is integral 0 to t f of u g of t minus u du. Okay, so I simply used convolution definition there. Fine. Now I have to substitute. What is f of u? Now look at the highlighted, yellow highlighted part, please, next to it. What is f of t for us? F of t is t. So what is f of u? U. Okay. Similarly, what is g of t for us? G of t is e power t. Look at the 4th and the 5th steps, please. G of t is e power t, isn't it? So what is g of t minus u? Now look in the highlighted part. What is g of t minus u? E power t minus u. Simply replace t by t minus u. That is all. So g of t minus u is e power t minus u. Fine. So now I want you to substitute f of u and g of t minus u in the definition. So come to the left now again. I'm talking about the 2nd step from the last. Okay. So I wrote the definition for convolution. I wrote integral 0 to t f of u g of t minus u du. Now I'm going to substitute. What is f of u? U. What is g of t minus u? E power t minus u. Okay, du. Now listen carefully. All you have to do now is integrate this, and then you would have found x. Okay, step 5 is over. So all I have to do now is integrate. How do I integrate this? Now listen carefully. This integral is with respect to u. So what's the variable here? It says du. So what's the variable? U is the variable. So t is a constant. So what can I do? I can take that e power t outside the integral. This is just to simplify. Okay, u is the variable, so t is a constant. So what is e power t minus u? It is e power t into e power minus u. So you can take that e power t outside because it's a constant, because u is the variable. Okay, I hope you understood. E power t is a constant because du. See, if the integral says du, what does that mean? U is the variable and it's a single integral. So t is a constant. That's why we're taking e power t outside. Fine. Okay. Now I have to integrate what I have left. Now this is simple integration by parts. Simple integration by parts. Okay. So how do you integrate? What is integration by parts, by the way? Integral of u dv equal to uv minus integral v du. Look at the highlighted one. That's integration by parts formula. Okay. So I'm going to use that here. So what is u? U is u only for me. U is u only. What is dv? dv is e power minus u du. Okay. So what form is this now? U dv. So when I use integration by parts, what will this integral be equal to? It will be equal to, remember e power t is outside. E power t into u into v. What is u into v? U is u only. Into v. What is v? Now listen carefully. dv is e power minus u du. Right? So what is v? From dv, how will you find v? You have to integrate. Okay? So what is integral of e power minus u? It is e power minus u divided by minus 1. Okay? Between the limits 0 to t. Don't forget the limits. Minus integral 0 to t minus integral, what's the formula? V du. What is V? Just now we wrote V. What is V? E power minus u by minus 1 into du. Du is du only because u is u, du is du. Have you understood? I hope all of you understood the step. This is simple integration by parts that I've used. Okay? All right. Now let's substitute. So all you have to do now is simplify. This is going to be really easy. Now e power, look at the second step, e power t into. I substituted the limits. Upper limit is t. So minus t into e power minus u minus t. Upper limit, u is replaced by t. Okay? Minus. Lower limit is 0. When you replace u by 0, the entire term vanishes. So I have not written the lower limit. Okay? Minus of minus is plus. What is the integral of e power minus u? It is e power minus u by minus 1. Isn't it? You divide by the constant. So e power minus u by minus 1. Between the limits 0 to t. Second step over. Now go to the third step. E power t into minus t, e power minus t is written as it is. Minus of. I've taken that minus 1 outside. Okay? And then now apply the limits. E power minus t minus, when you replace u by 0, what is e power 0? 1. Okay? So what is this equal to? E power t into minus t, e power minus t. Take the minus sign inside. Minus e power minus t. Minus of minus is plus 1. Okay? Now take the e power t also inside. So can you tell me what is e power t into e power minus t? What is e power t into e power minus t? It is 1. Because e power minus t is 1 by e power t. Okay? So e power t into e power minus t is 1. So take the e power t inside. You will get minus t into 1 minus e power t into e power minus t is 1 plus e power t into 1 is e power t. Have you understood? So I hope this was easy for you. This is convolution theorem and I wanted you to know that as well. Okay, that's the reason I thought I will use convolution theorem for this problem because it was possible. So this is what we did. We first used convolution theorem and then we used convolution definition and then we simply integrated using integration by parts and then we've simplified. Okay, so we found x. X is over. We've come to the end of the problem. All you have to do is now find y. How will you find y? Now that you know x in terms of t, how will you find y in terms of t? That last step, step 6, just substitute x in one of the two given equations to find y and then you're through. Okay, so which equation will you choose? Let's decide. Let's go back to the question. Okay, all right, I have two equations. Look at equations 1 and 2. I have two equations. Now I need to find y. Okay, I know x, I need to find y. Now sadly, both the equations have y dash. They don't give us y, isn't it? They don't give us directly y. Both the equations have y dash only. So I can choose one of the two. I'm going to choose the second equation because second equation looks a little simpler. I will choose 2. So I'm going to substitute x in equation 2. Okay. From equation 2, can you tell me what is y dash? What is y dash from equation 2? Y dash is 3x dash plus 5. Let's go back. Y dash is 3x dash plus 5. I'm substituting x in equation 2. Okay. Now, so what is this equal to? 3 into, what is x dash? What do you mean by x dash? X dash is dx by dt. So, if this is x, what is x dash? Differentiate this with respect to t. What will you get? Minus 1 minus 0 plus e power t. Differential of e power t is e power t only. So, minus 1 plus e power t. So, I've substituted for x dash. 3 into minus 1 plus e power t plus 5. So, when you simplify, what is y dash? 2 plus 3 e power t. Fine. Now, I've only found y dash. I have to find y, remember. Now, what is y dash? Y dash is dy by dt. How will you get y from dy by dt? You have to integrate with respect to t, isn't it? So, that's exactly what I've done. Integrate with respect to t. So, from y dash, you will get y. And what about the right hand side? What will you get when you integrate a constant? When you integrate 2, you will get 2 into t. Please remember you're integrating, you're not differentiating. If you differentiate 2, you'll get 0. But here you're integrating. So, from dy by dt, when you integrate with respect to t, you will get y. And that is equal to, integral of 2 is 2t plus 3 into, what is integral of e power t? E power t only. Plus the constant of integration. Remember, when you're integrating, you will get the constant because I don't have limits here. So I'll get the constant of integration. So what is my aim now? To find that c. I need to find what c is. That constant c is. How do I get that? By simply using the initial condition given in the question. See, this equation phi has y and t in it. So what is the initial condition given in the question regarding y and t? Look at the question. Question says when t is 0, y is 0. Use that here simply. When t is 0, y is 0. Substitute that in equation phi. Replace y by 0, replace t by 0. So you'll get 0 equal to 0 plus 3 into e power 0. E power 0 is 1. Okay? Plus c. So what is c? Minus 3. So simply substitute c equal to minus 3 in equation phi. That will give you what y is. Have you understood? So we found x and y. Okay? So this problem was a little lengthy and it might have been a little difficult for you because we also used convolution theorem in between. But I promise when you work out more problems, it's going to be really easy. Okay? And the next two problems that I have, I'm going to use method of partial fractions. That's going to be really, really easy. Method of partial fractions is definitely better. So if you have a choice, always go for partial fractions. Okay, so we will see that in the next two problems. So for now, we are done with two problems. Okay, so I want you to recap along with me, okay, the 6 steps that I told you to solve simultaneous differential equations. So I'm telling you this again. This is a very, very important topic in Unit 4. It's very easy to score here. So this is always a question without subdivisions, okay? So, and it's also very popular for the examiners. I mean, you will have one question for sure from this topic. So please concentrate and do well, okay? So shall we go through the 6 steps that you have to do? What is step 1? Replace dx by dt by x dash, dy by dt by y dash. Step 1. What is step 2? Apply Laplace transform on both sides for both the given equations. What is step 3? Use L of x dash formula, L of y dash formula. Also use the initial conditions given in the question. Okay, simplify. Get equations 3 and 4. How should your equations 3 and 4 be? First L of x term, then the L of y term, then take all the other terms to the right hand side. Okay, step 3 is over. Step 4, what should you do? Treat this as 2 equations with 2 unknowns. Eliminate L of y or L of x. So eliminating L of y, you will get L of x. Okay, have L of x. That is step 4. What is step 5? From L of x, find x using inverse Laplace transform. Okay, that is step 5. What is step 6? Last step. Substitute this x value in one of the 2 given differential equations. That will give you y. And you're through. Okay. So I hope that you understood how to solve simultaneous differential equations, and I hope you understand what we have done so far. So let's just proceed. Okay, we have just 2 more, and then I'll wind up with that. I can see that a few students are raising your hand. I want you to listen to the next 2 problems. Maybe you'll understand this better. All right. Okay. So we go on to problem 3 now. Okay, I think I'm going to pause for now because you need to give your feedback. All right, please give your feedback. The polls are, the rating is open. Kindly give your feedback, students. Students, kindly give your feedback for this online session that you saw just now. Please give your feedback. Students, give your feedback, please. Kindly give your feedback. People who are, I can see a few of you raising your hands, and I guess you may not have understood certain things, but you know, I want you to listen to the next two problems as well. Kindly be a little patient with me. Listen to the next two problems, and still, if you have doubts, you can always see what can be done about it. All right. Okay, so I'm going to continue now. The next few, the next two problems are going to be easier because we're going to use method of partial fractions. All right, so that's going to be simple. All right, let's go ahead. Now, as I told you, every problem is going to be different in some way. All right, so if you actually have a look at the differential equations given in the question, what is different here? See, you have dx by dt and x in both the equations. I mean, in the second equation, you have dy by dt and y. Now, that was not the case in the first two problems that we did. Okay, so let's see where the problem is going to differ because of that. Anyway, now we're going to again solve using Laplace transform. There are two differential equations given, simultaneous differential equations. Again, you have the initial conditions given. So let's read the initial conditions. It says x is 2 when t is 0. So can you tell me what it means? If x is 2 when t is 0, it means x of 0 equal to 2. Okay. Similarly, y is 3 when t is 0. What does that mean? Y of 0 is equal to 3. Fine. So these are the initial conditions. Please remember them. We will use them later. All right. So let's start with the solution. So I want you to remember the 6 steps that I told you. Okay. Step 1. What are you going to do in step 1? Simply replace dx by dt by x dash, dy by dt by y dash. Okay. So that's how you get equations 1 and 2. So dx by dt is x dash plus 2x minus y equal to minus 60. Similarly, if you replace dy by dt by y dash, what do you get? Y dash minus 2x plus y equal to minus 30t. Step 1 is over. You've replaced dx by dt by x dash, dy by dt by y dash. Okay, let's go on to step 2. What do you do in step 2? You're going to apply Laplace transform on both sides. Okay, so simply apply Laplace on both sides. What will you get? L of x dash plus 2 into L of x. I can take the L inside by linear property. By linear property, L of the left hand side will be L of the first term plus L of the second term, like that. And you can take the constants out, okay, by linear property. So this is L of x dash plus 2 into L of x minus L of y equal to minus 6 into L of t. Fine? That's the first equation. How did I get the last equation? Applying Laplace transform for the second equation. So L of y dash minus 2 into L of x plus L of y equal to minus 30 into L of t. Have you understood? Step 1, step 2 is over. We've applied Laplace transform on both sides. Now what is step 3? Step 3, I will use the formula for L of x dash. I will use the formula for L of y dash. And I will also write down what is L of t. Okay, so let's go to the next page. So in the next page, I'm starting step 3 in the next page. One second. That's next page, right? Okay. What is L of x dash? Yes, L of x minus x of 0. Okay. Plus 2 into L of x minus L of y is written as it is. Equal to, what about, how did I get right inside? Look at the formula that I've highlighted in yellow. What is Laplace of t power n? It is n factorial by s power n plus 1. Okay. So look at right inside Laplace of t. What is Laplace of t? 1 factorial divided by s power 1 plus 1, which is s square. Okay. Now, how did I get the second equation? For that, you look at the last equation here in this page. What is Laplace of y dash? S L of y minus y of 0. Okay. And then minus 2 L of x plus L of y, I've written it as it is. Equal to minus 30 into Laplace of t. What is Laplace of t? 1 by s square. Now we saw. Okay. Now we are still in step 3. Use the initial conditions given in the question. So what were the initial conditions given in the question? X of 0 equal to 2, y of 0 equal to 3. Let's apply that here. Okay. And then I've got equations 3 and 4. Now this is the end of step 3. Now when you write equation 3 and 4, what should you remember? What is the standard form? Always write the L of x term first, then the L of y term, then take all the other terms to the right hand side, isn't it? So how will you get the L of x term? Now look here, look in the first step, very first step. I have 2 L of x terms, isn't it? So let's collect, let's bring them together. So if you bring them together, what will you get? S plus 2 into L of x. Okay. And then minus L of y. So I've written L of x term, then the L of y term equal to, right hand side I already have minus 6 by s square. How did I get that plus 2? Left hand side I have x of 0. No, x of 0 is 2. So that minus 2 when you bring it to the right hand side becomes plus 2. This is equation 3. Now to get equation 4, look at the second equation in the page. First write the L of x term. I have only one L of x term, minus 2 into L of x. So I've written that. Plus, how many L of y terms do I have? I have 2 L of y terms, the second equation. So bring them together. Okay. So S L of y plus L of y can be written as S plus 1 into L of y. That's what I've written in the last step. Equal to minus 30 by s square plus 3. How did I get this plus 3? Minus y of 0 is minus 3. So when you bring it to the right hand side, it becomes plus 3. Okay. So these are my equations 3 and 4. So always remember when you come to end of step 3, that is when you write equations 3 and 4, how should it be? L of x term, bring L of x terms together. L of x term, then the L of y term, all the other terms to the right hand side. Okay. All right. So step 3 is over. Let's go on to step 4. All right. Now before we go to step 4, what do we do in step 4? We're going to eliminate, we're going to treat equations 3 and 4 as 2 equations with 2 unknowns. Remember, eliminate one variable from the picture. So let's eliminate L of y. Okay. You can eliminate L of x also, but I'm going to eliminate L of y. Okay. Now, how do I eliminate L of y? Now listen carefully. Equation 4 has s plus 1 into L of y. Equation 3 has minus L of y. So to bring the same coefficients, can you tell me what you should do? You should multiply equation 3 by s plus 1 and add, isn't it? Equation 4 has s plus 1 into L of y. Equation 3 has minus L of y. So I'm going to bring the same coefficients for both. So I will multiply equation 3 by s plus 1 and add. So that's exactly what I've done in step 4. Okay. I multiplied equation 3 by s plus 1. Look there. I multiplied equation 3 by s plus 1. When you multiply throughout, you've got to multiply throughout completely. S plus 1 into s plus 2 into L of x. Okay. Minus s plus 1 into L of y equal to minus 6 by s square into s plus 1 plus 2 into s plus 1. I multiply throughout by s plus 1. And I have not touched equation 4. I have written equation 4 as it is. Okay. All right. Now look here. What is your aim? Your aim is to eliminate 1, right? So now I can eliminate L of y. What should I do? I should simply add the 2 equations. So adding L of y gets cancelled. I am left with an equation in L of x alone. Okay. So what do I get? Collect all the L of x terms together. What will you get when you add s plus 1 into s plus 2 minus 2? This is what you will get. But what is s plus 1 into s plus 2? It is s square plus 3s plus 2. Okay. And then the minus 2 that I have in the second equation. The whole thing into L of x is equal to. Now look at the right hand side. Right hand side, I've simply added the 2 equations. Okay. So what will I get? I'll get minus 6s minus 6 minus 30. The whole thing divided by s square. Because s square is common, I've simply added the numerators. And then what am I left with? Plus 2s plus 2 plus 3, which is 5. 2s plus 5. Okay. See, remember in step 4, what are you supposed to find? You're supposed to find L of x in step 4. So I'm going to have L of x in the left hand side, bring all the other terms to the right hand side. Okay. So that's my aim now. So what have I done? I've taken LCM. Please look at the third step. I've taken LCM. From there, I've taken LCM. What is the LCM? S square. So when I take LCM as s square, what will I get in the numerator? Minus 6s minus 36 plus 2s into s square plus 5 into s square. which is 2s cube plus 5s square in the numerator. The whole thing divided by s square. How did I get this s square plus 3s? That's from the left hand side. The left hand side, 2 and minus 2 get cancelled. So I'm left with s square plus 3s, no? That when you bring it to the right hand side, you will get s square into s square plus 3s. Have you understood? See, I've just taken LCM for the right hand side as s square. Okay? And after taking LCM, I've brought from the left hand side, I've brought that factor to the right hand side. So 2 gets cancelled, 2 and minus 2. So I'm just having s square plus 3s in the left hand side. That is what I've brought to the denominator. Have you understood? Okay. Now, if you look here, no, in the denominator, please look in the denominator. This s square plus 3s has a s common. So I've taken that s also outside. So that is how I'm getting s cube. Look at the last step. I'm getting s cube into s plus 3 because I've taken one more s common. Okay. Numerator is the same. I have not done anything to the numerator. 2s cube plus 5s square minus 6s minus 36. So this is L of x. This is L of x. So what is x? X is L inverse of the right hand side. Okay, so step 4 is over. We've come to step 5. Step 5 is finding x. How do you find x? By using inverse Laplace transform. Okay. Now, I'm going to use inverse Laplace transform to find what x is. Now, what I'm going to do is, as I told you earlier, convolution theorem is like out. Okay. I don't even have an option here to use convolution theorem. So I'm going to simply go for method of partial fractions. And as I told you, it's the simplest of all. Okay. So let's go for method of partial fractions. Now, you tell me. How will you factorize? See, first thing I want you to know something. Why are we going for the method of partial fractions? Because L inverse of this big expression, I don't have a formula. I cannot find it. So what do? I'm going to think about separating the factors. See, look at the denominator. I have s cube into s plus 3. So if I separate the factors, no, finding L inverse will be easy for me. That's why I'm going for method of partial fractions. Okay. Now, you tell me, I want you to think about it. Since we've done the recalling already for method of partial fractions, if you have some f of s divided by s cube into s plus 3, how will you resolve this into partial fractions? What is s cube? S cube is a linear factor. Please listen. S cube is a linear factor which is repeating. See, what is s cube? It is s minus 0 the whole cube. You understand? It is s minus 0 the whole cube. So it is a linear factor which is repeating 3 times. S plus 3 is also a linear factor, but it is not repeating. So when I go for partial fractions, how will I write this as? So I want you to concentrate on only the last step, the function that is inside the square bracket. I'm going to take that function, go for partial fractions. Now let's go to the next page. Let's see if you've all thought correctly. Okay, let's go to the next page. All right, this is method of partial fractions. So what have I done? I've taken the function that is inside the square brackets and I've written it as, please remember, s cube is a linear factor repeating 3 times. So what will I write it as? A by s plus b by s square plus c by s cube plus d by, what is the factor that is not repeating? S plus 3. Is that fine? I hope you have no doubts here. This is simply using case 2 from the recalling that we did. Now, I want you to take LCM in the right hand side. Okay, this is partial fraction. See, what is your aim now? Your aim is obviously to find the values of A, B, C, and D. So how are you going to do it? Take LCM. First step, take LCM. Okay. So what is the LCM for the right hand side? It is s cube into s plus 3. Fine. So when I take LCM, that's the numerator that I'll get. I hope you understand that step. AS square into s plus 3 plus BS into s plus 3. Simply taking LCM, I get that step. Now, I want you to look at the left hand side and the right hand side. Look at the left hand side and the right hand side. The denominators are the same. What's the common denominator? S cube into s plus 3. You see that? So since the denominators are the same, what can I do now? I can equate the numerators. So that is what I have done in the highlighted step. The yellow highlighted step, that is what I've done. I've equated the numerators on both sides because the denominators are the same. Okay? All right. Now, it's really easy to find values of A, B, C, and D. Let's see how we do it. Now, first thing, you have to look at the linear factors. Okay. Now, I have 2 linear factors. One is s minus 0. The other is s plus 3. Now, since s minus 0 is a linear factor, put s equal to 0. Similarly, because s plus 3 is a linear factor, put s equal to minus 3. So, these are the 2 values for s that you will give. Okay. So, when you put s equal to 0, just look here. When you put s equal to 0, you can immediately find the value of C, because everything else will become 0. When you replace S by 0, A will become 0, that term, B term will become 0, D term will also become 0. You can find the value of C. So when you put S equal to 0, left hand side is just minus 36. Right hand side, everything else becomes 0 except C term. C into 3. So what is C? Minus 12. Okay. All right. Next, what did I say? I said put S equal to minus 3. Why? Because S plus 3 is a factor. Okay. So when you put S equal to minus 3, what will you get? Left hand side, when you put S equal to minus 3, you're getting minus 27. Okay. Right hand side, when you put S equal to minus 3, A term will become 0, B term will become 0, C also will become 0. Only D will exist. So D into minus 3 the whole cube, which is minus 27. So what is D? D is 1. So I found C and D. Now I don't have any other linear factors, but I should find A and B. How do I do it? I will begin comparing coefficients on both sides. Okay? And I will always start with the highest power of S. What is the highest power of S in the left hand side? S cube. Okay? So start with the highest power of S. So comparing coefficients of S cube on both sides, what will you get in the left hand side? What is the coefficient for S cube? 2. So 2 equal to. What's the coefficient of S cube in the right hand side? See, there are two terms with S cube. One is A square into S. So what's the coefficient there? A. Plus, how else will I get S cube? The last term, look at the last term, DS cube. So what's the coefficient there? D. So 2 is equal to A plus D. I already know what D is. So what is A? A is 1. Okay. Next, I will compare coefficients of S square on both sides. So what is the coefficient of S square in the left hand side? 5. So 5 is equal to. What's the coefficient of S square in the right hand side? How many S square terms do we have? 3A. 3A is one S square term. Similarly, B. B is also S square term. And then I don't have any other S square term. So that is all. I already know what is A. Substitute the value of A here. You will get what B is. Have you understood? So what have we done? We have successfully found the values of A, B, C, and D. Okay. So just substitute back here in the first step. So what is this entire expression equal to in the first step? If you substitute for A, it's 1 by S plus 2 by S square minus 12 by S cube plus 1 by S plus 3. Fine. So just look here. See, look at the previous step. What is X? X is L inverse of this big expression. So what is X now? It is L inverse of, after resolving into partial fractions, it is 1 by S plus 2 by S square plus C by S cube. So minus 12 by S cube plus D by S plus 3. What is D? D is 1. See, now it is really easy to find L inverse because I've separated the factors. Now I have a formula. All I have to do is use it. So what is L inverse of 1 by S? See, if in case you do not know the L inverse formula, I've written it again in the side. I've highlighted it. Please look at the formula. What is L inverse of 1 by S? L inverse of K by S is K, where K is any constant. So L inverse of 1 by S is 1. Okay. What is L inverse of 2 by S square? So it is 2 into. L inverse of 1 by S power n plus 1 is T power n by n factorial. Okay. So L inverse of 1 by S square will be T power 1 by 1 factorial. Similarly, use the same formula. What is L inverse of 1 by S cube? It is T square by 2 factorial. That is how I get minus 6T square. Plus, what is L inverse of 1 by S plus A? E power minus AT. So L inverse of 1 by S plus 3 is E power minus 3T. Have you understood? So that is all. We've used partial fractions. We've separated the factors. And it was very easy for us to find L inverse. So finding S, X using inverse Laplace transform is over. Step 5 is over. So what's the very last step? Step 6. All you have to do now is substitute this X value in one of the two given equations to find Y. Okay. So let's substitute X in one of the two equations that we have. Which equation will you choose? You tell me now. I have two equations, 1 and 2. Which one gives you Y directly? That is what you have to see. Which one gives you Y directly? See, the second equation has Y dash and Y. You cannot find Y from there. First equation gives you Y directly. So let's choose one. Okay. Let's substitute the X value in equation 1 to find Y. So from equation 1, can you tell me what is Y? What is Y from equation 1? It is X dash plus 2X plus 60. Okay. X dash plus 2X plus 60. Okay. So this is equal to, substitute for X dash. What is X dash? It is dx by dt. Simply differentiate with respect to t. 0 plus 2 minus 12t plus e power minus 3t into minus 3. That is x dash. X dash is nothing but dx by dt. Differential of x. Okay. Plus 2 into, substitute for x. Just now we found x, substitute for x. Plus 60 that I already have. Simplifying this, collect all the constants, collect all the t terms, collect all the e power minus 3t terms. You get the answer. That's y value. 4 minus 2t minus 12t square minus e power minus 3t. So we found x and y, and hence the problem is over. Okay. All right. So I have just one more problem with me now. I thought I'll quickly go through. Let's just do this quickly. Okay. Because by now I hope you're all through with the procedure. Here also we're going to find inverse Laplace transform using partial fractions only. So if we cross this, you can be confident of doing any problem here. Fine. Okay. Let's go through this now. The fourth problem. Why is this problem different? Why have I chosen this problem? It's because the question has second order derivative. Did you see that? It has d square x by dt square. It has d square y by dt square. So it's again a differential equation. It's again simultaneous differential equations, but of second order. Okay. So, but you don't have to worry about anything. The procedure is exactly the same. Exactly the same. Only difference is usually we have x dash. Now we're going to have x double dash. Okay. All right, step 1. Let's start with step 1. What do? We replace d square x by dt square as x double dash because it's second order derivative, differentiating 2 times. Okay, x double dash plus 2x is equal to y. Similarly, what should you do with d square y by dt square? Replace it as y double dash. Y double dash plus 2y equal to x. So I have 2 equations. Fine. All right, step 1 is over. Fine. Now, I want you to please read the initial condition that is given in the question. Can you tell me what is given? It says at t is 0, x is 4. What does that mean? X of 0 equal to 4. Okay. What is the next initial condition? At t is 0, y is 2. What does that mean? Y of 0 equal to 2. Okay. All right. What's the next condition? At t is 0, dx by dt is 0. What does that mean? Dx by dt, you know, is x dash. So at t is 0, dx by dt is 0. What does that mean? X dash of 0 is 0. Okay. Similarly, at t is 0, dy by dt is 0. What does that mean? Y dash of 0 is also 0. Okay. These are the initial conditions given in the question. Anyway, now that we finished step 1, what is step 2? You tell me what is step 2. We're going to apply Laplace transform on both sides. Okay. So that's step 2. Let's go to the next page. We're going to apply Laplace transform. So what will you get? L of x double dash plus 2 into L of x is equal to L of y. Okay. And then look at the last step. Apply Laplace transform now. What will you get? L of y double dash plus 2 into L of y equal to L of x. Okay. That's how I'm getting the first 2 lines. Step 2 is over. We've applied Laplace transform on both sides. What is step 3? Use the formula for L of x double dash. Use the formula for L of y double dash. Okay, and then we don't have anything else. So only these 2 formulae we have to use. I hope you remember the formulae. What is L of x double dash? S square L of x minus S x of 0 minus x dash of 0. See, these are simple formulae. Please remember them by heart. Okay, when you remember these simple formulae, the problem becomes so much easier. Okay, plus 2 into L of x, I've written it as it is equal to L of y. Again, I've written it as it is. Now look at the fourth step. Fourth step. What is L of y double dash? I've got this from the second equation. Okay. So what is L of y double dash? S square L of y minus S y of 0 minus y dash of 0. It's the same formula that I'm using. Second derivative formula. Same formula. All I'm doing is replacing x by y. That is all. Okay. So S square L of y minus S y of 0 minus y dash of 0 plus 2 into L of y. I'm writing it as it is equal to L of x. Have you understood the fourth step? Okay. So now what should I do? I have to use all the initial conditions given in the question. Now look at the highlighted step in yellow. The highlighted yellow step. These are initial conditions that I've got from the question. Okay. So x of 0 is 4. Y of 0 is 2. X dash of 0 is 0. Y dash of 0 is 0. So simply use that here. Okay. Use that here. Get equations 3 and 4. Now when you get equations 3 and 4, what should you remember? I said first write the L of x term, then write the L of y term. Take all the other terms to the other side. That's what I said, right? So I hope you remember that. So let's look at the third step. From the third step, I'm writing equation 3. Look at the third step. S square L of x plus 2 L of x. So combine the L of x terms together. What will you get? S square plus 2 into L of x. So L of x term is over. Okay. Then you should write the L of y term. L of y term is on the right hand side. Bring it to the left. So what will you get? Minus L of y equal to. See, what is x of 0? X of 0 is 4. So minus 4s, when you bring it to the right hand side, will become plus 4s. And x dash of 0 is 0. So it vanishes. Okay? Alright, that is equation 3. How do you get equation 4? From the fourth equation. Look at step 4. I mean the fourth equation. Write the L of x term first. Okay? Now L of x is only in the right hand side. So when you bring it to the left hand side, what will you get? Minus L of x plus. Collect all the L of y terms. I have 2 L of y terms. S square L of y, 2 L of y. Bring it together. S square plus 2 into L of y. Okay? Equal to. Take all the other terms to the other side. Y dash of 0 is 0. It vanishes. Minus s y of 0 becomes minus 2s. When you bring it to the right hand side, it becomes plus 2s. Have you understood? Step 3 is over with this. We have successfully brought 2 equations, 2 unknowns. What are the 2 unknowns? L of x, L of y. Now what should you do in the next step? You should eliminate one variable from here. Either eliminate L of x or L of y. Okay. Now let's eliminate L of x because we've been eliminating L of y so many times. Let's eliminate L of x now. Now listen carefully. In equation 3, what is the coefficient of L of x? S square plus 2. In equation 4, what is the coefficient of L of x? Minus 1. So what should you do to eliminate L of x? You should multiply equation 4 by s square plus 2. Isn't it? So that's exactly what I've done. I have not disturbed equation 3. I've only multiplied equation 4 by s square plus 2. Okay? Because what are we eliminating? L of x. So let's go to the next step. Next page. Okay. So equation 3, I've written it as it is. Okay. Equation 4, I multiplied by s square plus 2. What will you get? Minus of s square plus 2 into L of x. Plus, I already have a s square plus 2. I'll get s square plus 2 the whole square L of y equal to, what about right hand side? Right hand side 2s into s square plus 2. Fine? Multiplying equation 4 throughout by s square plus 2. This is what you get. Now, what should you do to eliminate L of x? Should you add or subtract? You should add, isn't it? That's how it will get cancelled. So add both the equations. So L of x gets cancelled. Now what happens to L of y term? I will get s square plus 2 the whole square minus 1. When you bring all the coefficients of L of y together, s square plus 2 the whole square minus 1 into L of y is equal to, right hand side I'm simply adding. What will you get when you simply add? 4s plus 2s cube plus 4s. Okay. So from this, what should you find? You should find L of y. So have L of y in the left hand side, bring all the other terms to the right hand side. Okay. So that's what I've done. L of y is equal to 2s cube plus 8s divided by, what will you have in the denominator? See, what is s square plus 2 the whole square? It is s power 4 plus 4s square is the 2ab term plus 4 is the b square term. Now plus 4 minus 1 will give me plus 3. So that's how I have s power 4 plus 4s square plus 4 minus 1 is 3. Okay, I hope you understood this step. I'm talking about the fourth step. L of y is equal to 2s cube plus 8s in the right hand side divided by s power 4 plus 4s square plus 3 from the left hand side I've got. Okay, that's the denominator. Now, this is L of y. Now, what should you do? Obviously, you're going to go for partial fractions, right? So when you want to go for partial fractions, you have to obviously factorize this first. So how do I factorize this? It's a little tricky because what is the power of s here? It's 4. It's a 4th degree equation. How do I factorize this? The easier thing is, the good thing about here is, I have only s power 4, s square, and then the constant term. So how do I factorize? I want you to look at the yellow highlighted one now. Yellow highlighted portion. Please look there. What I've done is, I put s square as t in the denominator. Now when you put s square as t in the denominator, what will the denominator become? Tell me. It will become t square plus 4t plus 3. Do you understand? Why am I doing this? Because I want to factorize the denominator. Okay. So simply put s square as t. You will get t square plus 4t plus 3. Now what is t square plus 4t plus 3 when you factorize? It is t plus 3 into t plus 1. Okay. And what is t? T is s square. So bring it back to s square. So what's the denominator now? It is s square plus 3 into s square plus 1. Okay. So now I have L of y equal to 2s cube plus 8s divided by s square plus 3 into s square plus 1. So what is y? Y is L inverse of the right hand side. So what is my aim now? I've come to step 5 where I'm going to find y using inverse Laplace transform. Now please listen. Now how do I find L inverse of this? First thing, I have to separate the factors. If I have the factors together, finding L inverse is difficult. How do I separate the factors? I can go for method of partial fractions. Now look at the factors carefully and you tell me what should you do? What will be the numerator when you go for partial fractions? When you resolve this into partial fractions, the denominators are two factors. Both are quadratic. Did you notice that? Both are quadratic. They are of degree 2. S square plus 3 is of degree 2. S square plus 1 is of degree 2. And I cannot factorize this further. So both are quadratic factors. So when you write this as partial fractions, I've just taken the expression inside the square bracket. I've taken only that expression and I've equated it to as plus b by the first quadratic factor plus cs plus d by the second quadratic factor. I'm doing this because both are quadratic factors. I'm using case 3. When we did the recalling, I'm using case 3. So now all you have to do is find the values of a, b, c, d. So you know partial fractions, right? So take LCM. Right hand side, I've taken LCM. Okay. Now look at the left hand side and the right hand side. Look at the denominators. Both are the same. Both are the same. Therefore, I've equated the numerators. Okay. So the yellow highlighted step, I've equated the numerators on both sides. Now, here I don't have any linear factor. So I cannot give any value for s. So what should I do? I should straight away go to comparing coefficients on both sides. So that is what I've done. What's the highest power of s here? Highest power of s is s cube. So compare coefficients of s cube on both sides. So what will you get? S cube coefficient is 2 in the left hand side. Right hand side, it is a plus c. Take it as equation 5. Next, compare coefficients of s square on both sides. See, there is no s square in the left hand side. So 0 equal to. What's the coefficient of s square in the right hand side? B plus d. Take it as equation 6. Next, compare coefficients of s on both sides. Okay. What is the coefficient of s in the left hand side? 8. 8 equal to. What's the coefficient of s in the right hand side? B. I'm sorry. A plus 3c. Okay. A plus 3c. Take it as equation 7. Next, you can only compare constants. So compare constants on both sides. See, there is no constant in the left hand side. So 0 equal to. Right hand side, what are the constants? When you multiply b with 1, b. And similarly, when you multiply d with 3. So b plus 3d. Now, it is really easy for you to find the values of a, b, c, d. Isn't it? Because you have 4 equations. Now take equations 5 and 7. Take equations 5 and 7. Simply do 7 minus 5. What will you get? 2c equal to 8 minus 2, 6. If 2c is 6, what is c? 3. Once you find c, substitute in 5 to get a. A is minus 1. Similarly, I want you to use equation 6 and 8. See, both are equal to 0. Simply subtract the two equations. You will get d equal to 0. If d is 0, b is also 0. Substitute in 6. If d is 0, b is also 0. Fine? So now you know all the 4 constants. That is all. So substitute a, b, c, d in the first line. The very first step. Substitute for a, b, c, d. Remember, b and d are 0. So what is this expression equal to? It is equal to minus 1 by s square plus 3 plus 3 by s square plus 1. Isn't it? So that's exactly what I've done. Substitute a, b, c, d here. What is y? Y is L inverse of this expression. Okay. So y is L inverse of, what is this expression now? A by s square plus 3 plus c by s square plus 1, because b and d are 0. So minus 1 by s square plus 3, minus 1 into s by s square plus 3, plus 3 into s divided by s square plus 1. Have you understood? I'm simply substituting for a, b, c, d in the first step. B and d are 0. So what does this first step become? It becomes minus 1 into s by s square plus 3 plus 3 into s by s square plus 1. That is what I've written here. Okay. Y is this. So we've separated the factors successfully. Now writing L inverse is really easy because simply use the formula. What is L inverse of S by S square plus A square? Look at the highlighted step. It is cos AT. So what is L inverse of minus S by S square plus 3? It is minus cos root 3t because A square is 3. So what is A? Root 3. Okay. Plus 3 is a constant. What is L inverse of S by S square plus 1? Simply cos t. So we've successfully found y. And to find x, what should you do? Substitute y in one of the two given equations. So that's exactly what I've done. Okay, I've substituted it in which equation gives you y. Sorry, I'm going to find x, right? I'm going to find x. I found y. I'm going to find x. So which equation gives you x directly? Equation 2. So substitute in equation 2. So what is x? X is y double dash plus 2y. X is y double dash plus 2y. Find y double dash. You know what is y? Please look at the highlighted step in the right. Or you know what is y, right? So from y find y dash, then find y double dash. Differentiate 2 times. So I have substituted that here. So x is y double dash plus 2 times y. Y you found just now. So I have substituted for y and I simplified. That's how I find x. So I hope this was clear. Solving simultaneous differential equations. We have covered all varieties of problems, and I hope you understand that if you follow in steps, you know, if I want to if you want me to summarize this, it's really easy. If you take it stepwise, it's going to be really easy. So, you know, this is what I've summarized. Step 1, simply replace dx by dt by x dash, dy by dt by y dash, d square x by dt square by x double dash, d square y by dt square by y double dash. That's the first step. What is step 2? Take Laplace transform on both sides. Okay. What are you doing in step 3? You're using the formula for L of x dash, L of y dash. You're also using the initial conditions given in the question, and you're getting 2 equations. You're naming them as equations 3 and 4. Okay. So you have 2 equations, 2 unknowns. What are the 2 unknowns? L of x, L of y. Okay. That is step 3. What are you doing in step 4? You're eliminating either L of y or L of x. Eliminate one variable from the picture. So if supposing you're eliminating L of y, then what will you get? You will get L of x. That is step 4. From L of x, how will you find x? That is step 5. X will be L inverse of the right hand side. So there you're using inverse Laplace transform. And how are you using, to find inverse Laplace transform, what are the 2 important methods that you should know? Convolution theorem, method of partial fractions. Okay. So use one of the 2 methods and find x. Once you find x, finding y is just substituting x in one of the 2 given differential equations. See which equation gives you y directly. Okay. And then find y. So you're through. So this is all it is. So when you work out more problems, you know, maths is all about that. You need to work out. You cannot just simply go through and say, okay, I'm done. You cannot do that. Because, you know, you don't know where you'll get stuck in the exam. So I've given 2 assignment problems for you to just work them out. I've given the solutions as well. I'm sure the more you work out, the more confident you will get, okay, in these topics. So I hope that this session was useful for you, and kindly work out more problems. Do not waste your holidays. Okay, make these sessions useful, and all the best to you. Okay, thank you so much. Thank you for listening to me patiently, and thank you for everything. Thank you.